Hello everyone, in this video we're going to be working on some transformation examples. So we're just going to be writing the transformations for these problems down here, problem number 1 and problem number 2. The first thing that we're going to start off with is problem number 1, and in this problem you'll notice that there is a negative out in the front. So since there is a negative, we are going to reflect over the x-axis. So reflect over x-axis. The next thing that we're going to look at is this 1/2. And that is going to be our a value. It's the one in front of the parentheses. If a is less than 1, it's going to be a vertical shrink. If a is greater than 1, it's going to be a vertical stretch. So 1/2 is less than 1. So this is going to be a vertical shrink by a factor of 1/2. Okay, then we're going to work with the number up in the parentheses. Remember that b, that's not actually a transformation. B is part of the parent function, so it's a little bit weird. This parent function is 1.2 to the power of x. Really weird, but just trust me on that. Okay, then we have x minus h up at the top. So the h is going to be weird. Since this is x minus 1, that means that our h value is positive 1. So since that is positive, that means we're going to shift right. You could also just think it's the opposite. So since it's minus 1, that's going to be shifting right, not shifting left. So this is going to be right 1. And then the last one, we have this plus 3 on the end, and that's just going to be either up or down. Since it's greater than 0, that's going to be shifting up. Up 3. Okay, so let's just go look and see what these look like in Desmos. All right, so let's go to Desmos, and we're going to type in, and let's revert this back, y equals 1.2 to the x. This is the parent function that we're looking at. So let's look at our very first transformation, which was the negative out in the front. All right, so you can see that whenever you put a negative out in the front, it does reflect over the x-axis. So let's look at our 1/2 now. And you can see that instead of being like this, like it was, it's now going, so it's shrinking down to this black graph right here. So shrinking down, pancaking out a little bit more, that is your vertical shrink. Okay, let's look at the next one that we were working with, which was the x minus 1 up in the exponent. And you're going to see it shift to the right 1. Okay, so there it went, shifting to the right 1. All right, and the last thing that we're going to look at is the plus 3 on the end, and you're going to see it go up 3. So here it goes up 3. Up 3, up 3. Okay, anyway, I think that you guys get the idea, just shifting up 3 there. And you can see the y-intercept is also shifting up 3. Okay, so let's look at the next one. Looking at problem number 2. There is not a negative out in the front, so it's not going to be a reflection over the x-axis, but we do have a 3 right here. So 3 is your a value. If it's less than 1, it's going to be a vertical shrink. If it's greater than 1, it's going to be a vertical stretch, like that. So 3 is greater than 1. This is going to be a vertical stretch by a factor of, and yes, you do have to say that, 3. Okay, then we're going to look, the 5, remember that is part of the parent function, so we're actually not going to work with that. But we're going to look with this x plus 1/2. Since it is plus, that means that this is really x minus negative 1/2, so that's why it's shifting left. But you can also just think that this is the opposite, so positive usually means right, but now it means left. So this is going to be left 1/2. And then we have this minus 4 on the end, that's just going to go down 4, because that's our k value, and k being less than 0 means we're going to shift down. Okay, so let's just go look at this in Desmos with its parent function. And the new parent function is going to be 3 to the 5 to the power of x. So this is our parent function, and let's just type in our very first transformation, which was the 3 out in the front. And what you're going to notice is that this, instead of going like that, is going to be more narrow. It's going to go sort of straight up like this. So just watch what happens. Okay, and you can see that it's stretching upwards. It's getting a little bit more narrow. It's kind of coming in right there. So this is our vertical stretch versus a vertical shrink. I just wanted to show y'all. This would be a vertical shrink, so moving down a little bit, but this is a vertical stretch, so moving up a little bit more. Okay, and then we're going to look at the x plus 1/2. All right, and you can see that this is shifting to the left 1/2. So if you are confused about which one is left and right, just go type it in and see where it moves. And then the last thing is going to be the +4 on the end, or the -4 on the end. And you can see this is just going to move down 4. Okay, so let's go back. I hope that you guys enjoyed this video. Don't forget another thing as well. Transformations are the same thing for all functions. So if I was looking at problem number 2, this is actually the same transformations. Glad I made this note because I almost forgot. All right, the same transformations as y equals 3 times x plus 1/2 squared minus 4. This is actually the exact same transformations. We have the vertical stretch, we have the plus 1/2 with x, and then we have the minus 4. It's also the same transformations as the absolute value of x plus 1/2 minus 4, and it's the same transformations as 3 square root of x plus 1/2 minus 4. So these are the same transformations for all functions, and just keep that in mind with your a, your h, your negative out in the front, and then the k, the shifting up and down. Okay, hope that you guys enjoyed this video. Please stay tuned for comparing exponential functions. Goodbye.